All right, hello there. Good to see you. Well, I can't really see you. You can see me, so good to see me, I guess. I don't know. All right. Welcome back to Finite Math. We are learning chapter 6, which is symbolic logic, and we are ready to begin section 2, which is where we learn how to do a truth table, which is fun stuff. I really enjoy these. They're kind of like puzzles. So let me get things set up here, make myself a little bit bigger. All righty. So in a truth table, we are going to consider any number of simple statements and then some sort of combination of those simple statements, which we call a compound statement. And the idea is going to be to determine whether that compound statement is true or false for every possible combination of true and false for the simple statements. So for instance, we'll have maybe a P and a Q. We'll consider every possibility of true and false for the two simple statements P and Q. So in other words, they could both be true. P could be true and Q could be false. P could be false, Q could be true, or they could both be false. And then the idea is going to be to take some kind of compound statement and determine whether that compound statement is true or false in each of those individual situations. Now, every truth table with two statements is always going to start off the same. These first two columns are always going to be exactly the same. If we have three statements, if we have a P, Q, and an R, then we're going to have 8 rows in that truth table because we need, true, 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 false, and so on. So we go through every single possible combination of true and false for P, Q, and R. There is a little rule here to know as far as how big your truth table needs to be. And that's just however many simple statements you have. If you just do 2 to that number, that'll tell you how many rows your truth table needs to have. So if you have 2 simple statements, well, 2 to the second power is 4. So your truth table will have 4 rows. If you have 3 simple statements, P, Q, and R, well, 2 to the third power is 8. Your truth table will have 8 rows. If you were to have 4 simple statements, then 2 to the fourth is 16, and your truth table would have 16 rows in it. So here it just asks us to give the number of rows for the truth table. So you say I have an N and I have an R, that's 2 simple statements. So again, just 2 squared tells me that truth table will have 4 rows. Here I have a P and a W and an M and a B and a Z and an E. That's 1, 2, 3, 4, 5, 6. 6 simple statements. So I just need to do 2 to the 6th, which is 64. That truth table would have 64 rows in it. Now, don't worry, we're not going to do any truth tables with 64 rows, although I think it would be fun. You don't need to worry about that. Okay, so example 2, we've got a compound statement here. We're going to construct a truth table for it. So first of all, I need to set up a column for each simple statement. So I need a column for P, and I need a column for Q. Okay, and now I need to fill in the trues and falses for P and Q. And I'm going to do that just the same way we did up here. We say P and Q are both true, or P is true and Q is false, or P is false and Q is true, or both of them are false. Okay, so we've got every possible combination of true and false for our simple statements. And now we just have to figure out whether this compound statement would be true or false. And here's how we're going to go about that. I'm going to add a column in my truth table for every piece of this compound statement. And I'll show you what I mean by piece here in a second. The final column in my truth table needs to be this compound statement. The final column in your truth table will always have a heading that is the compound statement that you're constructing the truth table for. Okay, so let me walk you through and show you how this will work. I'm just going to make my way from left to right in this statement. And the first thing I see here is that I want to negate the P statement. So I need to have a column in my truth table for the negation of P, or I like to call that a not P column. Now I'm going to fill in the trues and falses for that column once I get all the column headings set up. Okay, so I've got a not P column. Then I come across this conjunction symbol. So I'm going to need to do a conjunction. If I'm going to, and conjunction means and, right? We learned that in our last section. If I'm going to do this and statement, I need to have a column for each of the things that I see on either side of that conjunction symbol. Now, on one side, I see a not P, and I have a column for not P. On the other side of the conjunction is this not Q. So I'm going to need a column for not Q as well. Now that I've got a not P and a not Q, now I can do the conjunction. So now I can do not P and not Q. And that's going to be the final column of my truth table. I'm just not going to use the rest of that area over there. Sometimes we don't need all the room. Okay, so now we get to start inputting the true and false values in each of these columns. So in this negation of P column, or the not P column, I'm just going to put the opposite of whatever P is. So if P is true, not P is false. P is true, not P is false. And then for these two falses, I'll put in trues. For the not Q column, I do the same thing, but I use Q. So instead of going true, false, we'll do the opposite of that, and we'll go false, true, false, true. Okay, now I'm ready to do the conjunction of these two negation columns. Now remember the rule for a conjunction, and the rule is only true if both are true. So I'm going to look through these two columns, and anywhere that these two columns are both true, I'm allowed to put a true in the conjunction column. Now I notice the only time that both of these are true is in this last case right here. So I'm allowed to put a true in this column. All the other ones, it is not the case that both columns are true. And so I have to say that the conjunction is false. Remember, this is only true if both are true. This is the final truth table. We're done. What we have determined here is no matter what your P and Q represent, no matter what simple statements they represent, it could be like P could be the sky is blue and Q could be the clouds are white. And if both of those statements are true, this compound statement is false. If the sky is blue, but the clouds are not white, this conditional statement will be false. If P is false and Q is true, this statement's false. And if P and Q are both false, this compound statement actually ends up being true. If the sky is not blue and the clouds are not white, think about what this means. This says the sky is not blue and the clouds are not white, right? That if these two are false, then this statement's true. All right, and that's all we're doing in a truth table. Let's do another one here for P and Q. So I'll need a column for P and a column for Q. And I'm going to go ahead and do true, 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 false, false, true, false, false. Okay, now let's work up to this compound statement. Now, right off, again, I see a not P. So I'm going to put a P negation column in there. Then I see another conjunction. And so I look on either sides of the conjunction. I have a not P column. I have a Q column. So we are ready to do not P and Q. Great. So we can do that conjunction. Then I see a disjunction symbol. So I see an or symbol. So I'm going to look on either side of the or symbol. And I do have a column for what's on the left side of the disjunction symbol. The right side of the disjunction, though, is this not Q. So I need to have a not Q column. And now I have a column for the things on either side of my disjunction symbol. So I can go ahead and do not P and Q. I have a column for that, or not Q. Okay, so let's put in our trues and falses. Now again, for not P, that's easy. I just do the opposite of the P column. So instead of true, true, false, false, I'll make it false, false, true, true. Now I'm going to do the conjunction of not P and Q. So I'm looking at these two columns here, not P, Q, right? So I want not P and Q. And the rule for conjunction is only true if both are true. So in this column, I'm only allowed to put a true if both of these are true. And we see that happens right here. We have two trues here, so I can put a true in that column. That's the only time that those two columns are both true though. So everything else has to be false. Okay, now in my next column, I'm doing not Q. So I'm going to go down the Q column and just do the opposite. If I see a true, I'll put a false. False becomes true. True becomes false. False becomes true. And now we're ready to do our final disjunction. Now we're going to be doing the disjunction of the not P and Q column. That was this column. We're doing the disjunction of that with our not Q column. So we're looking at these two columns here, and we're doing an or. We're doing a disjunction. And the disjunction rule is only false if both are false. So in this column, I'm only allowed to put in a false if both letters here are false. And I see the only time that I get a false and a false is in this very first situation. Everywhere else, I see at least one true going on. So disjunction, only false if both are false. Here, these two are both false. So in this column, I can put a false. Everywhere else, the two values are not both false. So I have to put true in the rest of those columns. And that completes our truth table for that statement. All right, let's move on to one final truth table here. This time, our truth table has three statements. We have a Q and an R and a P. Now, it doesn't matter in what order you put the P's, Q's, and R's in your truth table. I just always like to start with P first, and then Q second, and then R third, although again, it really doesn't matter in what order you put those. All right, let's make our way from left to right here in our compound statement and build up to this final compound statement. So I see a not Q, I need a not Q column. There we go. Then I see a disjunction. So in order to do that disjunction, I need the not Q, which I have. I'm also going to need a not R. So we'll do a column for that. Now that I have a not Q and a not R, now I can do this disjunction. So I'll do not Q or not R. Next thing I see working from left to right is a conjunction symbol. So I'm going to look on both sides of the conjunction, which is this parentheses and this parentheses. Now I have a column for this parentheses. I need to work on this one. So I see there's a not P there. I don't have a not P yet. So let's put in a column for not P. Then I see a disjunction. So I need to look on either side of the disjunction and see if I have a column for those things. I see a not P. I do have a not P column. How about not Q? Oh yeah, I already have a not Q column over here. So I'm good to go on this disjunction. I can do not P or not Q. All right, so now I have a column for this parentheses. It's right here. I have a column for this parentheses. It's right here. So I am ready to do that conjunction. So I'm going to write that whole thing out. Not Q or not R. And not P or not Q. Okay, great. So now it's time to put in our trues and falses. With the P's, Q's, and R's, this can be a little bit trickier. I'm still going to start with P and Q the same way I did before and just go true, 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 false, false, true, false, false. And now in every one of these situations, I'm going to let R remain true. Now I'm going to go through and do that same pattern again. True, 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 false, false, true, false, false. And this time I'm going to have R be false in each of those situations. And that will give you all the combinations of true and false for P, Q, and R. Okay, here we go. Let's do it. We're going to start with not Q. So I'm going to look down the Q column and do the opposite of that. So true becomes false, false becomes true, true becomes false, false becomes true, true is false, false is true, true is false, false is true. We're going to do the same thing with R. True is false, true is false, 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 and then we have 4 falses, so those will become 4 trues. Awesome. Now I'm ready to do an or with the not Q and the not R. We're going to do a disjunction here. The rule is only false if both are false. So I'm just going to go down here and look for anywhere that these two columns are both false, and I'm going to put a false in this column. So right off the bat, false and false gets a false. Let's see, here's another one right here. False and false gets false. And I believe that's it. That's the only place where I have false and false. So those are the only places I'm allowed to put false in this column. Everywhere else is going to be true. Okay, now we need a not P. So I'm going to go down the P column. True becomes false, true becomes false, false is true, false is true. Again, true, true, false, false will become false, false, true, true. Easy enough. Now we're ready to do another OR here, this time with the not P column and the not Q column. So I have to look at these two columns here. Again, we're doing a disjunction, so the rule is only false if both are false. So right off the bat, I see false and false, so I'll put a false here. Let's see, anywhere else do I see false? There's another one, false and false, so I can put false. And it looks like that's going to be it. Everywhere else is going to be true. Okay, we're ready for our final conjunction. And for this conjunction, we're using the not Q or not R column. That was this one right here. And we're also using this one, which was the not P or not Q, which is this column right there. Now, ultimately here, we're doing a conjunction. So I'm going to look through these two columns, and our rule is only true if both are true. Only true if both are true. So I'm going to look here and see anywhere that they're both true. So right here, I see two trues, so I can put a true. And there's another one, true and true. I can put true. Anywhere else? Oh, these last three, true, true, right? See that? These last three are, everything's true. So I can put true on all those. Everywhere else is going to be false. Okay, so there's a truth table for 3 simple statements. Great. The last thing that we need to do here for this video is to discuss equivalent statements. Now, I'd like you to pause your video in just a moment and do a truth table for each of these 2 statements. Okay, and we're going to show that these 2 statements are equivalent is the idea. But I'd like you to do a truth table for each of these 2 statements. And you can kind of use this as a simple way to practice doing a truth table. Okay, so on your own, pause your video in 3, 2, 1, pause. And voila. Okay, this is what your 2 truth tables should look like. If they don't look like this, you can kind of check that a little bit, see where you may have made a mistake. But I'd like you to notice that these 2 statements have the exact same final column. That final column is identical in both cases. False, 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 true, false, 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 true. That means in every combination of true and false for P and Q, these 2 compound statements always have the same truth value. And that's what we mean by statements that are equivalent. Statements that are equivalent will always, whenever one's true, the other one has to be true. Whenever one's false, the other one has to be false. That makes them equivalent. So 2 statements are equivalent if they have the same truth value in every possible situation. Okay, now we do have one more thing to do here in section 2, and you know what, let's just go ahead and do it so we don't have to make 2 videos for this section. Okay, so our last part of section 2 here is to learn what are called De Morgan's laws. Now, De Morgan's laws are a way for us to easily negate a compound statement. Okay, so again, De Morgan's laws are all about negating a compound statement, and that means finding a statement that means exactly the opposite of the original statement. Now, I'm not going to do truth tables for these. You can certainly do that to verify these things, but if you did use some truth tables, you would find that this statement here is exactly equivalent to this one, and the same thing for these other 2. Now, this statement is exactly equivalent to this one. Now, if we just kind of look at those a little bit, by the way, notice that the triple equal symbol is used to show that 2 statements are equivalent to each other. What we're doing here in this one is taking a disjunction, an or statement, and negating it. Down here, I'm taking a conjunction or an and statement and negating it. You'll see what happens here when we use De Morgan's laws is we sort of kind of distribute the negation. Now, we're not actually using the distributive property, but if you want to think of it that way, that's really kind of what it looks like. So if we want to negate this disjunction, we negate the first statement, we negate the second statement, but you'll notice that the or changes to an and. Same thing down here. If we were starting with a conjunction, we can negate the first statement, negate the second statement, but the and changes to an or. Okay, so again, we have those De Morgan's laws written here again. I don't know why they're written twice, but these statements here are the exact same as these statements here. So we've got a couple of statements here, a few statements here that we're going to use De Morgan's laws to write the negation of. So in this case, the basketball is round. I'm going to represent that as statement P. The train is fast. Let's represent that as statement Q. And then this statement, since there's an and there, would become P and Q. Now, what this wants me to do is to negate that whole statement. Now, we know that De Morgan's laws say that the equivalent statement would be the negation of P, and we do the negation of Q, and the and changes to an or. So, and I'm not going to write this whole thing out just because there's no reason for me to take the time to do that in a video, because you can pause it and do it yourself. But the negation would be the basketball is not round, or the train is not fast, right? So the basketball is round and the train is fast. We're looking for the statement that has the opposite meaning of that. So we negated that statement. And the negation of that statement would be the basketball is not round, or the train is not fast. Okay, let's do the same thing down here. She makes the bed will be statement P. I do not make the bed will be statement Q. And you'll notice that there's an or there. So this statement symbolically would be P or Q. We want to negate that statement. So De Morgan's law says that if you want to negate that entire statement, you negate the first statement, negate the second statement, and then the or becomes an and. So the negation of this statement would be, she does not make the bed, and I do make the bed, right? Originally, Q said I do not make the bed. So if I negate that, it'll be I do make the bed. So she does not make the bed, and I do make the bed. Down here, Mary won't try will be P. Ellen won't succeed will be Q. We've got an and, so this statement is P and Q. We are told to negate that whole thing. So we will negate P, we'll negate Q, change the and into an or. And now the negation of this statement is Mary will try, because remember originally it said won't. So this would be Mary will try, or Ellen won't succeed. Okay, here's some other ones down here that are just symbolic. So let's negate this entire statement. So the way that we're supposed to do that by De Morgan is this is the disjunction that we are negating around. So we'll negate the first part. Well, this is already the negation of P. So if I negate that, it'll just become P. The or turns into an and then we're supposed to negate this whole quantity here. So let's negate that whole thing. Now here we have another quantity being negated. So let's go ahead and use De Morgan's laws just on this part of the statement. So again, De Morgan's law says negate the Q, so not Q. Negate the not P, which just turns into a P. And then the and becomes an or. Now I do need to put parentheses around that whole thing. But there we have the negation of that original statement. Let's do it one last time here with example E. I'm going to negate this whole thing. So I'll start my negating this first parentheses, this first group. I'm just going to negate that whole thing. The and will become an or, and then I'll negate my not R, and it just becomes an R. Okay, here I have another compound statement that I'm going to negate. So I'll negate the not P, turning that just into a P. The or becomes an and then I'll negate the Q. Now I'm going to go ahead and keep that whole thing in parentheses and then leave the rest alone. And there we have the negation of that original statement. Okay, so that will do it for section 2. That'll do it for section 2. In the next section, we're going to learn about conditional statements. So section 3 will be about conditional statements, which are in the form like if then. All right, we will see you in that video. Goodbye.